Hey pre-calc, welcome back. Our objective today is going to be to graph quadratic equations. Again, a lot of this should be review for you. I'm going to force a pause on the screen. You know what to do from here. All right, so let's dive into some review here. You don't need to write anything down. I would just like for you to match the parabolas on the left with the equations on the right. What I'd really recommend you doing is think about transformations and how that depicts your vertex. So for example, the function 1 has been shifted to the right 4 because inside's opposite, correct? And down 2. So if I think about my standard quadratic function, y equals x squared, and go to the right 4, down 2, I must be on parabola B. Notice that this is also opening up, and your a value here is positive, which matches. So I'm going to match parabola B with equation 1. I'm going to force a pause on the screen. Can you do the other 3 from here? All right, answers are on the screen. You can pause if there's something you got wrong and double check yourself here. I'm forcing another pause on your screen. Can you please copy example 2? And we'll do the first one together. Okay, we're back. So we just want the vertex and axis of symmetry here. Once you've got the vertex, you've pretty much got the axis of symmetry already. Again, really think about your transformations. This first function has been shifted left or right 5. It's been shifted right 5 because inside's opposite, and up or down 2. Up 2. So the vertex, remember originally the parent function, the vertex is at 0, 0. So now since I've gone right 5 up 2, my vertex is at 5, comma 2, right and up. And then my axis of symmetry is always going to be x equals the x value of the vertex. So just x equals 5 will be the axis of symmetry. So that will cut the parabola perfectly in half. I'm going to force a pause on your screen. Actually, before we do that, this first f of x, does it open up or down? It's going to open down, and that's because of your leading coefficient. Your a value here is negative. So this parabola is going to have a vertex of, or at 5, 2, and it's going to open down. Okay, now for real, I'm going to force a pause on your screen. Can you try the next 2 on your own? Hit continue when you're ready to check your answer. All right, I've got the answers on the screen, so you can double check. Make sure you put a little check if you got it right with a different colored pen or pencil. If you got it wrong, just put the correct answer. If you need to pause to take a bit more time on this, feel free to do so now. Force pause on your screen. Can you please copy the function for example 3? All right, we're back. So finding the vertex and axis of symmetry is really straightforward when you are in vertex form, right? But when you're in standard form, it's not quite as easy to spot. So let's see if we can take this function and get it into vertex form so that we can easily identify the vertex and the axis of symmetry. So any ideas here? Okay, what if I rewrite this as f of x equals x squared plus 8x? And then leave a little bit of space and then put the plus 19. Does that ring a bell at all? So we're going to complete the square here in order to get this into vertex form. So go ahead and write what I did, leaving that little space. Okay. Now we're going to complete the square for the first 2 terms. Okay. So remember, you take your b value and you have it. So half of 8 is 4, and then take 4 and square it. So it's going to be 16, right? Now I can't just add 16 because that would be totally changing the function, but if I also subtract 16 over here, I'm fine, right? Okay, so now let's go ahead and look at these first 3 terms. So if I look at that trinomial, x squared plus 8x plus 16 would factor into x plus 4 times x plus 4, right? Also known as x plus 4 quantity squared, right? Okay, and I still have my f of x equals, and then 19 minus 16 is going to be 3, right? Okay, and now we can easily identify our vertex is going to be negative 4 comma 3, and what's my axis of symmetry? X equals negative 4. Good deal. All right, however, we probably don't have to complete the square every single time, especially if we don't have like nice integers to work with. What if there are some fractions or decimals. So can we derive this for any quadratic so we don't have to complete the square each time? The answer is yes. I will derive it for you in class and post a separate video for virtual students if you're interested in where this formula comes from. But for now, I'm going to go ahead and force a pause on the screen. Can you go ahead and copy what I have? So if you have a function, a quadratic function in standard form, instead of completing the square every single time like we did that last time, the vertex is found by taking negative b over 2a, where b is your linear coefficient and a is your quadratic coefficient, okay? So negative b over 2a gives you your x value of your vertex, and then if I want to find the y value, I would just plug the x back into the original function. So force a pause on your screen, go ahead and copy this for me. All right, force a pause on your screen. Can you please copy this function for example 4? All right, we're back. So it says find the vertex and axis of symmetry of the function, then write the equation in vertex form. Okay, so let's first find the vertex, which you can see this would not be that fun to complete the square for, especially since you've got this leading coefficient that's different from 1, and you've got, these fractions and such, because I know how much you all love fractions. So let's go from our previous formula right here. Let's find negative b over 2a first, okay, and that's going to be the x value of my vertex, which is also going to be the axis of symmetry, right? So, okay, let's write our formula, negative b over 2a. All right, b is what? B is a negative 8/3, so I'm going to have negative, and then negative 8 over 3, all over 2 times a, and what is a? A is 2. All right, so let's clean this up a bit. The numerator, a negative times a negative, is a positive, so positive 8/3. The denominator is 4, and dividing by 4 is the same as multiplying by 1/4, right? So I can reduce, because 8 divided by 4 is 2, so I am getting 2/3 for the x value of the vertex. Now to find the y value, we're just going to take that 2/3 and plug it into the original function. So I want to find f of 2/3. And I'm going to force a pause on the screen, let you go ahead and do that. All right, this is what I got when I plugged in, so let's clean it up together. Remember to do PEMDAS, remember to do exponents first. So 2/3 squared is going to be 4/9 times 2. 4 times 2 is 8, so I got 8/9 here, and then just multiplying straight across. 8 times 2 is 16, 3 times 3 is 9, so negative 16 over 9, and then I still have my negative 20 over 27. Let's go ahead and work with these fractions that have a denominator of 9 first. So 8 minus 16 is negative 8, still over 9, and I still have this negative 20 over 27. All right, let's get a common denominator here of 27. So I would need to multiply top and bottom by 3. 8 times negative, let's do negative 8 times 3 is negative 24. All right, so I've got negative 24 minus 20 in the numerator, so that's negative 44 in the numerator with a common denominator of 27. All right, so coming back to answer some of these questions here, my vertex is going to be 2/3, comma, negative 44 over 27. My axis of symmetry is going to be what? That's going to be x equals, don't forget your x equals. Usually my MATLAB has that written in for you already, but just be mindful of that, equals 2/3, right? Then it says write the equation in vertex form. So we've got our vertex, right? We know that we've gone to the right 2/3 and down negative 44 over 27. So for the equation, we've got y equals, I'm going to leave a little bit of space here, x plus or minus 2/3, right? Inside's opposite, squared, and then plus or minus here, minus 44 over 27. Now the only thing that's left is there an a value that's different from 1? Well, it's not that hard to check. Just go look at your a value here. It's the same a value in vertex form as well, right? So there is our equation, and that is example 4. All right, I'm forced to pause on your screen. You don't need to write all of example 5, but will you please write the parts that I highlighted? All right, so we're given the vertex and one other point that the parabola passes through. So let's start with what we know. I'm going to go y equals, and I'm going to leave a little bit of space for a. And I know that if I'm in vertex form, it has to look like x minus 4 quantity squared, and then plus or minus 1 here. Plus 1. Good. All right, now again, the only other piece I might have in vertex form is going to be an a value other than 1. So let's go ahead and put an a in there. Now ideas, how could we find a? Yeah, let's go ahead and plug this point. What would we plug in for, or where would the 6 go? We would plug 6 in for this x, and the -7 we would plug in for y, and then we would solve for a. So it'd look something like this. -7 equals, a is what I'm trying to find, 6 minus 4 quantity squared plus 1, right? All right, I'm forced to pause on your screen. See if you can simplify and solve this for a. Hit continue when you're ready to check your answer. All right, so we should have gotten -2. So this, if I want, let's come back over here. Let's plug in that -2. So I've got y equals -2, quantity x minus 4 squared plus 1. This would be my function in vertex form, and if I wanted to get it in standard form, I would simply expand everything and combine like terms. So for example, make sure you do PEMDAS first. Expanding x minus 4 quantity squared would be x squared minus 8x plus 16, and I still have this plus 1 out there. And then again, just distribute, combine like terms. So I'm confident you can do the math there, but we should get -2x squared plus 16x minus 31 as our final answer, and we can always check on Desmos, right? So I've graphed what we got as our final answer, and I'm verifying, okay, yeah, the vertex is 4, -1, and it does indeed go through the point 6, -7. All right, example 6, don't write anything yet, let's just read it together. A football is thrown at a point 6 feet above the ground at a velocity of 60 feet per second at an angle of 45 degrees with respect to the ground. The path of the football is given by the function, here's what I'd like for you to write down, f of x equals -0.0168 x squared plus x plus 6. Where f is the height of the football in feet and x is the horizontal distance from the quarterback in feet, what's the maximum height reached by the football? Okay, well first of all, what kind of function is f of x? It's quadratic, right? And a quadratic function would look like a parabola. Now does this parabola open up or down? It opens down because your leading coefficient, your a value, is negative, okay? So if I've got a parabola opening down, do you agree that the maximum, or let's ask this, where does the maximum occur? It occurs at the vertex, okay? So keep in mind our formula to find the x value of the vertex. It goes like this, -b over 2a, let's write that. Now b is what? B is 1, so -1 over 2 times what is a? A is that -0.0168. Don't lose that negative, okay? All right, so I'm going to plug that into my calculator. So let me come over here. All right, so I've plugged it in. An approximation is it's about, 29.762. And that is in feet. Now, is that my final answer? It's not, because that's just the horizontal distance from the quarterback. If I want the actual height, I'm going to need the y value, because f of x, which is y, is the height, right? So I want to plug in this 29.762 into my function, which you can kind of do that straight into the calculator. You can also do it a little bit faster on a calculator or Desmos. I've got the function plugged in into y1 already, or in Desmos you can just call it f of x. And then I want to find f of my answer, right? Or in our case, again, we plugged it on the 84, I plugged it into y1. So if you go to your home screen and go alpha trace. It's going to give you all your functions there. I plugged mine into y1, and I want to input this 29.762, right? A couple ways to do that, but if you hit your up arrow, it will highlight it, and then hitting enter will kind of copy and paste it into your parentheses there. And this kind of avoids some rounding errors as well. So if I hit enter, all right, my function value is 20.881 when at the vertex, right? So final answer, let's do this. F of that 29.762 was approximately 20.881. All right, and that is all I have for us today. Don't forget to write a summarizing sentence or something you want to be mindful of as you start the assignment. I want to reiterate, the sentence does not have to be in English, okay? So if you are more comfortable in another language, I am bilingual, so I totally understand how sometimes we think in a different language than what's being taught to us. So if you're more comfortable writing that sentence in a different language, feel free. All right, I will see you all next time.